Today we were looking at Unit 1, Lesson 3, Scaled Relationships. Our goals for this lesson: I can reason about the corresponding distances and corresponding angles in a scale copy. I can describe the effect on the scale copy when I use a scale factor that is greater than 1, less than 1, or equal to 1. And I can explain how the scale factor that takes figure A to its copy, figure B, is related to the scale factor that takes figure B to figure A. We started looking at shapes like these, where we can't actually count the length of the sides of the shape because they're on a diagonal. And we talked about in class the reason for this is if I draw this diagonal line in one box, and I can draw this diagonal line in a box, they both go through one box, but they are different lengths, so we can't count them. And we looked at the angles. So if I find angle CDCB, and I move that over to its corresponding angle HGF, it does indeed seem to be the same. And the same thing for LKJ. And then we'll try that with CDA. And I move it over here. Yep, GHI. And KLI. I guess it's not GHI, it was GHE. And KLI. Corresponding angles are all congruent. And then if we try DAB and we move it to its corresponding angles, they are all the same. And then finally checking angle ABC, we find those corresponding angles are all the same. So we know that they have corresponding angles the same. What do we do about finding a scale factor if they are, in fact, scale copies? Well, we can look at distances. And so we're looking at the distance from D to B and the distance from A to C. Well, in my shape, DB is this horizontal distance. So I want to look at HF and LJ. LJ is 2. 1, 2, 3, 4, 5, 6 for HF. So if I come back here, HF, and I'm not going to put the bar over top because I'm not talking about a line segment. I'm talking about a distance. So HF is 6, LJ is 2. And then looking at that other distance, CA. So the vertical distance, 1, 2, 3, 4, 5, 6, 7, 8, 9 for GE. And 1, 2, 3 for KI. Well, what do we notice? Some of us noticed that going from the horizontal to the vertical was multiplied by 1.5. This is times 1.5. And this is times 1.5. Also, we could look from one shape to another. So from DB to HF, we multiplied by 1.5. From AC to GE, we multiplied by 1.5. From DB to LJ, we multiplied by 1/2. And from AC to KI, we multiplied by 1/2. So they are scaled copies. And the scale factor from ABCD to EFGH is 1.5. And the scale factor from ABCD to IJKL is 1/2. So we don't have to just check side lengths. We can check any vertical or horizontal distance. We need to look at 3 things. Do they have the same shape? Do they have the same angles? and are all sides multiplied by the same scale factor? Those are the three things we must check. Then we did a little card sort. You were to sort the cards by the scale factor used to create figure B from figure A. And what can we say about the scale factors that produce larger copies, smaller copies, or same size copies? So let's take a look at these cards and see what we can find. And so in card 1, the width was 2 on A, B it was 4, and we're going from A to B, so the scale factor is 2. 2 times 2 equals 4. Card 2, the height of A is 1, the height of B is 3, so to go from A to B, we are multiplying by 3. Card 3, we had to use distances since none of the lines were horizontal or vertical. So I chose this distance, which is 8, and its corresponding distance is 4. So to go from 8 to 4, we're multiplying by 1/2. Card 4, this distance is 3, this is 1. So to go from A to B, our scale factor is 1/3. Card 5, I looked at the distance across the circles. So that one is 2. This one is 6. To go from 2 to 6 means our scale factor is 3. Card 6, this side is 9. This is 3. To go from A to B, the scale factor is 1/3. So looking at card 8, I use this distance here, which is 2. Its corresponding distance is also 2. To go from A to B, I multiply by 1. All right, so now if we look at all these ones where my B shape is bigger than my A shape, so card 1, card 2, card 9, card 10, card 5, we notice that our scale factors, in these cases they're all whole numbers, but they're whole numbers bigger than 1. There were 2 cards where the A and the B shape were identical sizes, and we notice the scale factor is 1. And then the remaining cards had shape B smaller than shape A, and the scale factor is smaller than 1. So when the scale factor equals 1, the copy is the same size. When the scale factor is bigger than 1, the copy is bigger than the original. And when the scale factor is less than 1, the copy is smaller than the original. Now they also want us to take a look specifically at cards like card 1 and card 7, where it's basically A and B flipped, which one was bigger and smaller. And the same thing here with card 10 and card 13, where we started with A being smaller and then A was bigger, but they're the same shapes. And we noticed something here, that the scale factors were reciprocals of each other. And so if we know the scale factor from A to B, then the scale factor from B to A is the reciprocal of the scale factor from A to B.